Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hadi bin Muhammad Saidi. Right now, I will be presenting about the introduction of our mini project. So, we are given a task to do a mini project, and we decided to make a project that is an alternative of piping watering system for plantation. So, we decided to make a smart watering robot car. So the robot car is suitable for small plantation or indoor plantation. To move the car, we does not need gasoline or plug-in wire because we only use 18650 rechargeable lithium-ion battery. So it's very easy, and it also have tracking module so that it can move by tracking the line that we have made. We also install infrared receiver and Bluetooth receiver so that there are two ways to control the car, which is by remote control and by using the apps on your phone. When you are using the tracking line mode, you do not need to worry if there is something in front of it because it also have obstacle avoidance because we install the ultrasonic sensor to the robot car. So how can a robot car spray the plantation? It is easy. The robot car can move automatically and we just have to put the water sprayer on top of the car and it will do the job for you. So let's see how the smart watering robot car looks like.
Upon that list, she said, where'd you wanna go? How much you wanna risk? I'm not looking for somebody with some superhuman gifts, some superhero, some fairy tale bliss, just something.
Nowadays people like to have mini plantation or mini pots plantation inside of their house, but sometimes they do not have time to watering all their plants. So the objective of our mini project is first of all to make a simple system and cheap. Second, can watering all the plants needed. Third one is easy to use and can be used daily. And the last one is to develop a robot car that can move automatically to the desired track. So for the problem statement, during this day, people in Malaysia love to garden at their house, love to buy pots plant, buy mini pots plants inside their house. But in Malaysia, we have erratic weather. It is very hard to taking care of all the plants. If we want to make a fully piping watering system, it will cost us quite high. Because of that, we created smart watering robot car. It is easy to use, it is cheap, and it is reliable. So that's all from me. Thank you.
Hi, my name is Hafiza. I will present to you about the component that we use for our project. We use one Uno R3 board as an open source microcontroller board which is able to read input and deliver the output. And also, we use Wi-Fi expanding board that can connect to various modules. Besides that, we have a basic component that needed to make a car robot, which is 4 tires, 2 acrylic chassis and 1 battery case. This is 4 input component that we use, which is 1 ultrasonic sensor, 3 line tracking sensor, 1 IR receiver module, 1 Bluetooth module. Ultrasonic sensor used to detect the distance measurement between obstacle and car. Line tracking sensor used to make sure that car is moving on the line that have been set up. And IR receiver module is a wireless control of the smart watering car, and we use Bluetooth module to control the car by using handphone. Okay, 4 output component is 1 SG90 servo, 4 DC motor and L298N motor driver board. DC motor and L298N motor driver used to move the smart watering robot car. SG90 servo used with ultrasonic sensor to avoid obstacle. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafizuddin bin Hashim. Today, I will continue our presentation about programming flowchart for our project. Firstly, we must know what flowchart is. A flowchart is a graphical representation of steps. It was originated from computer science as a tool for representing algorithm and programming logic, but had extended to use in all other kinds of processes. Nowadays, flowchart play an extremely important role in displaying information and assisting reasoning. They help us visualize complex processes or make implicit the structure of problems and tasks. A flowchart can also be used to define a process or project to be implemented. As you can see, this is a smart watering robot car flowchart that show how the robot works. This flowchart uses decision shapers intensively in representing alternative flow. First thing first, start, then power on. Power on the smart watering robot and it will scan environment to generate map and location. In our project, we are use line tracking sensor as a device to plan route for watering process. After that, watering process will be started and it will follow the route. It will follow the route that has been planned until the route has been finished. If during the watering process, they have something that obstacle, ultrasonic sensor will detect and stop the watering process. If not, the robot will continue follow the routes until finish and watering process will stop also when the route has been finished. Finally, we can power off the smart watering robot car and we finish with end. That's all from me and I will pass to the next presenter.
Assalamualaikum. My name is Muhammad Haikal Syahmi. I will continue present about the circuit diagram. So basically, our robot have four main functions. One of it is Bluetooth function, which is able to control the robot by using smartphone. Then the other function is the robot able to move by using the driver setting. Then the other function for the robot is it able to move under the line tracking function. Lastly, it can move itself as it have ultrasonic sensor to avoid any obstacle. First of all, as our robot will use Bluetooth system, therefore we have decided to use HC06 Bluetooth device as a device connector. So here is the circuit diagram for Bluetooth system that I have sketched in the Freak-C. HC06 will connect to our nano shell, or also known as expansion board. This one. So this board will be attached to the Uno board. Then this is the circuit diagram for L298N motor. We will have basically four motors which they will connect to the L298N motor driver board. Then we'll connect to the expansion board which is at the input of 2, 4, 5, 6, 7 and 8 input. Next is our line tracking circuit diagram. It is related to the circuit diagram for L298N as we only add 3 line tracking device for right, center and left sensor. All of them will be connected to the digital pin at expansion board at pin 11, 10 and 9 respectively. Lastly is our ultrasonic sensor and servo. Both of them will connect to the analog input pins. As example, for ultrasonic sensor, it will involve at pin A0 and pin A1, while the servo component will involve with at pin A2 at the UNO expansion board. This is how to attach the UNO expansion board, or also known as nano shell board, to the UNO R3 board. However, the function of all the components also will be determined through the coding system, which will be explained by my friends later, and followed by the function and result from our project. So that's all for me. Thank you.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Haziq Hilmi bin Razman, and I'm going to continue our presentation with coding of this project. For this project, we have 10 different codings based on different components, but in this presentation I only present for 4 components or 4 codings, because if I want to present all the codings in the presentation, it might take a long time to present. Okay, for the first coding is Bluetooth module that we use in this project. First, we need to declare the car app key value, and in the void setup we need to declare the serial begin, and void loop we use the if statement to judge whether the serial port receives the data or not. For the second coding is motor driver L298N. First, we need to define LPWM at pin 5 and RPWM at pin 6, where it is used to control the speed of the motor. After that, we need to declare the integer pin LB at 2, pin LF at 4, pin RB at 7, pin RF at 8, which is used to control the turning of the motor. And then we need to void setup to make the pin mode of those that we declared just now, because those code are for the output. And after that, for the void loop, we need to make for the advance and speed. Advance and the back, which is advance is moving forward and back is backup or moving back. After that, we have the void set speed function for the setting speed, void advance going forward, void turn R, which is turning right, void turn L, turning L, turning left, void stop for stop the car, and void back for backup. For the third coding is line tracking car. This coding just same like driver motor, but it has a little bit addition from the driver motor's coding. First, we need to define the sensor left, where we put the sensor at the left, middle and right. Unsigned car as SL, which is state of left sensor, unsigned car as M, state middle sensor, and SR for the state of right sensor. After that, define LPWM just like driver motor's coding right just now. Integer pin LB, LF, RB, RF. After that, unsigned car LPWM val equals to 120, which is the speed of the left wheel at 120 in initialization, and unsigned car RPWM val equals 120, and we need to declare the integer car state equals to 0 for the state of car moving. And after that, we need to do the void sensor IO config, void sensor scan, void M control IO config, which is for the initialize the function of IO of motor driver. And for the void set speed, just like motor driver just now, but it has the addition for the unsigned car PWM. for the setting function of speed, void advance, void turn R, void turn L, void stop, and void back. After that, we need to do the void setup for the sensor IO config, M control IO config, for the motor controlling the initialization of IO, and for the void loop we use the if else statement for the sensor scan. For the last coding is ultrasound obstacle avoidance car. We use ultrasound sensor to detect or avoid car from hit the obstacle. What we need to do is we need to include the servo because it is connected with the servo. Define LPWM pin 5, RPWM pin 6, just like coding before. Pin LB equals 2, pin L equals 4, pin RB equals 7, pin RF equals 8. And we need to add the servo, my servo, volatile DL, DM, DR. After that, we need to do the float check distance to check how far the car will stop from hit the obstacles. And we need to do the void detect obstacle distance and void setup for servo with the output and input. And for the void loop, we used if and else statement for the check distance. This one, we use a few if else statement inside the if else statement. I think there are 3 or 4 if else statement inside the if else, the bigger one if else statement. For the void set speed, just like coding before, function of the setting speed, void advance going forward, void turn R turning right dual wheel, void turn L turning left, and void stop for stop, void back for backup. So basically from the first coding, it is related from until the last coding. It just from first it is the basic one, and then after that we need to add inside that coding and add another one until we complete the all together the coding. So I think that's all for me. Thank you.
Assalamualaikum, my name is Muhammad Firdaus bin Bakri, and I'm gonna discuss about the results that we got from our Arduino project. Based on the basis where we have accomplished the coding and several plan for our smart water car project, which means we'll be using 3 types of mode, which is the ultrasonic sensor, which led to obstacle avoidance, and next is the line tracking mode, which the car follows the line that has been created, and last we can manually control the smart car. So first we will be install the sprayer water gun on top of the smart car and be good to go. For ultrasonic sensor, as you can see in the video, the sensor is well performed and detect a front obstruction and simultaneously transmit data to the Arduino. When the distance between the robot and the object in front of it less than like 20 centimeters, the robot car comes to a halt, which means it stops, detects whether there is an obstacle in the left and right front, and then the car will move to the direction where is no object in front of the sensor. Next is the line tracking mode. As you guys can see, which the car is perfectly follows the line that has been created, that called a line track, or specifically a black track that the path can be detected by the sensor. But there are some delays in the processing the signal when the car is about to turn. It is because the feedback signal will be analyzed by the Arduino, and the driving motor will be controlled to modify the robot vehicle diversion. So last, the car is manually can be controlled by using the application that installed into the phone. For the advantage of the project, there are several errors that we found, and we know that the efficiency of the sensor is likely not 100% accurate. Sometimes when we are depending on the ultrasonic sensor, the sensor is ineffective and the car movement can cause an accident, as you guys can see in the video. I think that's all from me, and as a conclusion, this project was designed to reduce the use of workforce to be watering their plants and to make the watering process easier. This project can be a useful system if more innovation or development implement to the products. Thank you. Shout out for Haikal Syamil for the video, and Assalamualaikum.